All right, I want to look at solving what's called a quadratic type exponential equation. What these are, they look like this, where you've got two different exponentials, but on the exponentials, one of them has an exponent that's exactly twice the other one. And the reason that that's important is this: if you've got e to the 2x squared, that gives you e to the 4x. So we can factor it like it's a quadratic equation, but what we would do is like we would call e to the 2x. We could call that u. Then e to the 4x would be u squared. So we can take this and rewrite it as, let's see, u squared minus 9u plus 20 equals 0. And now we can factor this. U minus 5, u minus 4. And so u equals 5, u equals 4. We're not quite done though, because that's the answer in terms of u. We need to put it back in terms of x. So we'll replace each of these u's with e to the 2x. So we get e to the 2x is 5, e to the 2x is 4. So take the natural log of both sides. This gives you 2x is ln 5. This one gives you 2x is ln 4. And so we get x is 1/2 ln 5. And this gives us x is 1/2 ln 4. And notice you could take this and rewrite this one as ln of 4 to the 1/2 power. So that's ln of 2. So these are our two solutions to this equation. Now, usually what I'm going to do is going to be, I'm not going to write this stuff with the u's. What I would do here is I would take this equation and I would just factor it, keeping it all in terms of e to the x. Let's see, e to the 4x, the square root of that's e to the 2x. So I'd write this as e to the 2x minus 5, e to the 2x minus 4, and I'd just go straight from there. So let's do a few examples. This first one, we've got e to the 10x minus 2e to the 5x minus 15, and that's supposed to say equals 0. Somehow I lost the equals 0 on there. So let's solve that. All right, well, this is going to be e to the 5x, e to the 5x. Then we need two numbers that multiply to 15 and add or subtract to 2. So 5 and 3 will do it. Let's see. We need to make the 5 negative and the 3 positive. That way they add up to -2. And so my solutions here are, well, let's write the steps in. This gives me e to the 5x is -3. This gives me e to the 5x is 5. So if I take the natural log over here, this is going to give me 5x equals ln 5, where x is 1/5 ln 5. Now this other one, you might notice right off that this other side is not going to give us any solutions. A couple of ways you could see that. One is if you graphed e to the 5x, it's going to look like this. It's never going to go below the axis. So there's no solution to e to the 5x is -3. If you didn't catch that right off, if you just plowed straight through and you said, here's 5x equals ln of -3, x is 1/5 ln of -3, then you'd have to remember you can't take a logarithm of a negative number. So this right here gives you no real solution. So the only solution you get to this problem is this. Now, the way these work out, sometimes, on this one we had one, after we factored it, one thing gave us no solution and one gave us a solution. It can happen where both give you a solution, neither give you a solution, or just one gives you a solution. So let's do another example. E to the 8x plus 2e to the 4x minus 35 equals 0. Notice I wrote this one in on the notes. The same problem was written in there twice. So let's solve this one. E to the 4x is going to be what goes here and here. Then we need numbers that give you 35, so that's going to be 7 and 5. You can make the 7 positive and the 5 negative so that it adds up to plus 2. And I'm just going to jump straight from here to e to the 4x equals 5. E to the 4x equals negative 7. Now when you take the natural log over here, you get 4x is ln 5. So x is 1/4 ln 5. This right here gives you no solution. All right, I want to do one more because this last one looks weird. On this one, instead of it being an e, our logarithm is, or not logarithm, our exponential has a base of 3. So what we've got here, let's first rewrite it. 3 to the 2x minus 17 times 3 to the x minus 270 equals 0. So this is going to factor like this. This is going to be 3 to the x. And let's look at that. It's because when you multiply these two together, you get 3 to the 2x. And so then we need something here and here that will multiply to 270 and add to 17. I tried to pick numbers that were relatively easy to factor. 27 and 10 will work. If we make the 27 negative and the 10 positive, they'll add up to negative 17 and they'll multiply to negative 270. So this gives me 3 to the x equals negative 10. This gives me 3 to the x equals 27. All right, so this over here is going to give us no solution. And again, that's because if you graph out 3 to the x, it's going to look like this. It's never going to go negative. So this side gives you no solution. This side over here, you could take some logarithms and stuff, but you probably know that 3 cubed is 27. So we get that. If you didn't know that right off, you could just do x equals, well, do ln of 3 to the x equals ln 27. So x ln 3 equals ln 27. So x is ln 27 over ln 3. If you pop that in your calculator, it'll give you the 3.